Hello, my dear students. Once again, I welcome you all to KLS Gokte PU College of Commerce and Science, Belgavi. This is the lecture number 7 on the topic Structure of Atom. Myself, Mr. Akash Vasant Nesarkar, lecturer in Chemistry, Department of Chemistry. So let us see the contents of today's class. The first point we'll discuss about the difference between the orbit and the orbitals. The second point is we'll learn the shape of the orbitals. Third one, we'll try to understand what is node and nodal plane. And last fourth one, rules of electrons filling in various orbitals. And fifth one, electronic configuration of elements. So we'll try to cover up all these points in today's class. And these all points are very important for the final examination. So I request you to focus on the class. Now, the first one is a difference between orbit and orbital. The first difference is orbits represent the planar motion of the electron. The orbit represent what? The planar motion of the electron. Whereas in case of orbital, it represents the three-dimensional motion of the electron around the nucleus. So it represents the three-dimensional motion of the electron around the nucleus. Whereas orbit, they are circular in shape. They are circular in shape. Whereas orbital, they are different in shapes from each other. As I said, yes, orbital is spherical in shape, p orbital is dumbbell in shape. So orbitals are different in shape. Third one, it is well defined path that revolving electrons follow around a nucleus. So it revolving electron follow around a nucleus. Whereas in case of orbital, it is a simply region of a space around a nucleus where the electron is present. So it's very simple. The orbital is nothing but it is a region of a space around a nucleus where the electron is present. Four different. The orbits theory doesn't satisfy the Heisenberg uncertainty principle. So orbit does not satisfy the Heisenberg uncertainty principle, and maybe you have learned that uncertainty principle. It is difficult to determine the exact position and momentum of the revolving electron around the nucleus is nothing but is Heisenberg uncertainty principle, and the orbit theory does not satisfy that uncertainty principle. Whereas in case of orbitals, the concept completely complies with the Heisenberg uncertainty principle. Means what? It obeys the Heisenberg uncertainty principle. Next, fifth difference is the orbit can accommodate 2n square electron in the shells where n is the number of orbital. So orbit can accommodate 2n square electron. Whereas in case of orbital, only 2 electron can be present in an orbital. So s orbital, we can accommodate only 2 electron. Whereas in px, py and pz, here also in px orbital we can accommodate only 2, and py only 2, and pz also only 2 electrons. So in orbitals we can accommodate only 2 electrons. The last difference, the planar motion of electron can be designated by L, M, N, N, etc. Whereas in case of orbitals, the 3D motion of electron by S, P, D, F orbital. So remember, these are the important differences between the orbit and orbital. So don't get confused. Orbitals are nothing but what? S, P, D, F. Okay, and each orbital we can accommodate only 2 electron, and it is a simple region of a space around a nucleus where electron is present. For example, this is a px orbital, or you suppose py orbital. So this is a region where the electron is present. This is the region where the electron is present. Okay, and each orbitals are of a different shape. S orbital is different from p orbital, p orbital is different from d orbital, and f orbital is also different in size. So each orbitals are different from each other. So these are the orbitals. Okay, an orbit is different. Okay, have you understood? Fine. Next, shape of a orbital. So shape of the orbital is also important. So here we have the tabular column. In first we will learn about only s orbital, in second p orbital, in third column we have d orbital, and fourth column we have f orbital. So these are the four orbital as we have know, that is s, p, d, f. Now we'll learn when we will get the s orbital, when we will get the p orbital, d orbital, and f orbital is based on the quantum numbers. Okay, so the first column, the shape of s orbital. If the quantum number, azimuthal quantum number, that is L is equal to 0 and m is equal to 0, so s orbital have only one directional orientation, that is the probability of finding the electron in the same in all the direction. So if the value of L is equal to 0, m is equal to 0, then we get s orbital. We get what? S orbital. The size and the energy of s orbital with the increasing n will be like this. So 1s orbital, 2s orbital, sorry, 1s orbital, 2s orbital, the size is increasing, okay, as n is 1, 2, 3. So as n increases, the size of the s orbital is also increases. So 1s orbital is smaller than 2s, and 2s orbital is smaller than 3s, 3s orbital is smaller than 4s. So as the value of n increases, the size and the energy of s orbital is also increases. So this was the second point. Third, there is a no radial node for first orbital, since it is a starting from the nucleus. So this is your s orbital, and here you will not get any node. Node means we will learn that later on. So in s orbital there is a no radial node or planar node is present. Are you getting? So no node is present in the s orbital. This point is very important, remember. So we have discussed the 3 points. First, if L is equal to 0 and m is equal to 0, then we get s orbital. The value of, sorry, the size and energy of s orbital increases with increasing n value, and there is a no radial node in s orbital. Next one is a p orbital. The first one, if L is equal to 1 and m is equal to plus 1, 0 and minus 1, then we get p orbital. We get what? P orbital, that is px, py and pz. If L is equal to 1, we get p orbital, and m is equal to plus 1, 0 and minus 1. So we get p orbital. Means there are 3 p orbitals which is symbolized px, py and pz. Okay. If value of L is equal to 1, then we get 3 orbital px, py and pz. The next one, the shape of p orbital is dumbbell, in which the two lobes on an opposite side separated by the nodal plane. So this one is important. So what it is? The shape of the p orbital is dumbbell, like this. It looks like a dumbbell. The two lobes, so these are the two lobes, first and second. These two lobes are opposite side, separated by what? So here we will get a nodal plane. So here we will get what? Nodal plane. So this is what? The nodal plane. This is what? The nodal plane. So these are the two lobes separated by the nodal plane, and the p orbital is in dumbbell shape, remember. Next one, p orbital has directional property. Directional property means what? These p orbitals are along the three axes. So this we can say pz, this we can say py, and this we can say px. So it is directed along the three coordinated axes x, y and z, and therefore it is having the directional properties. So these are the 3 points of the p orbital. Next one, shape of a d orbital. So if L is equal to 2, so M can have the value minus 1, minus 2, minus 1, 0, plus 1, plus 2, and okay. So it shows that d orbital has a 5 orbitals, okay, which are dxy, dyz, dzx, dx square minus y square, and dz square. So first dxy, dyz, dzx, dx square minus y square, and dz square. So these are the 5 d orbitals are present if the value of L is equal to 2. Are you getting? Now, the shape of the d orbital is a dumbbell, but shape of the dz square is double dumbbell in shape. It has directional property. So shape of the d orbitals are double dumbbell. It is called as a double dumbbell. For example, dxy. Okay, so it is like this. So it is double dumbbell like this. So the shape of the d orbitals are what? Double dumbbell. It is double dumbbell. We can say it is double, and it has a directional property as a p orbital. So it is directed along 3 coordinated axes. Now, last point is what? Each d orbital is identical in size, shape, and energy, but dz square orbital is exceptional. Degenerate orbital. It is known as a degeneracy. So all the d orbital is having the same size, shape, and energy except the dz square. It is an exception. Now, last one is what? F orbital. If L is equal to 3, then M can have the value minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. It shows the F orbital is having 7 orbitals. The F orbital is complicated in shape. So, we cannot study the shape of the F orbital because each orbital shape is different from one another, and therefore it is complicated in shape. So just remember, if the value of L is equal to 3, then F orbital. If value of L is equal to 2, then D orbital. If value of L is equal to 1, then P orbital. If L is equal to 0, then it is S orbital. So this is about the orbitals, suborbitals, and their properties. Okay, and also we have learned about their shape. Okay, F orbital is circle in shape, p orbital dumbbell in shape, d orbital double dumbbell in shape, and F orbital shape is what? Somewhat complicated. So this is the main thing you have to remember, because this is all basic things. In first year chemistry, you all learn about the basic things of a chemistry. Okay, so you should know what is a s orbital, how many p orbitals are there, how many electrons we can accommodate in p orbital, d orbital, and f orbital. Okay, so that is very important. Shape of the orbital, as we have learned, see, this is a px orbital, where this is what? Nodal plane. So one nodal plane is separated two lobes, as we have discussed just, right? So two lobes are separated by one nodal plane. This is dxy. So it is double dumbbell in shape. It is looking like double dumbbells. So these orbitals are separated by two nodal plane. One is like this and another is like this. Now this one is 3d exit. This is also two nodal plane it is having. So all the lobes are separated by two nodal planes. Now py, it is py. So two lobes are separated by one nodal. This is shape of the pz. So it is px, py, and pz. So two lobes are separated by one nodal plane. Now this is 3d y z, two nodal planes, and this is 3d x square minus y square. This is having one nodal plane, and this is somewhat exceptional, as I said. So this is 3d z square. So this position, this one is a new, as we compare to all other shape like 3d xy, 3d yz, 3d zx, and 3d x square minus y square, the 3d z square. So we are having here this one is called as a collar. This one is called as a collar. So collar is present between the two lobes of the 3d z square. So its shape is somewhat different compared to 3d 3d xy, 3d yz, 3d zx, and 3d x square minus y square. And it is having also nodal plane. Okay, so this is the shape of a p orbital and the d orbitals. Now, what is node or nodal plane? As we are saying again and again, right? So, let us try to understand what is node and the nodal plane. Node and a nodal plane represent the region where the probability of finding an electron is zero. that is psi or psi square is equal to 0. Similarly, the nodal plane represent the plane having 0 probability of finding electron. So, see, node or nodal plane represent what? It is a simple region. It is a simple region where no electron is present. उस रीजन में क्या नहीं रहता? इलेक्ट्रॉन प्रेजेंट नहीं रहता. उस रीजन को हम क्या कहते हैं? नोडल प्लेन कहते हैं. Okay, so we are having the nodal plane. So that nodal plane is nothing but what? Some space or you can say some region where no electron is present. वहाँ पे इलेक्ट्रॉन absent रहता है, वहाँ पे इलेक्ट्रॉन प्रेजेंट ही नहीं रहता. उसी को हम क्या कहते हैं? नोड और नोडल प्लेन. जैसे कि अभी 1s ऑर्बिटल में एक भी नोडल प्लेन प्रेजेंट नहीं है, लेकिन 2s ऑर्बिटल में एक नोडल प्लेन प्रेजेंट है. सो सी, दिस वाइट पोर्शन इज व्हाट? नोडल प्लेन. इन दिस the white portion is what? Nodal plane where no electron is present. Now here see, in 3s orbital two nodal planes are present. The first one is here and second one is here. So two nodal plane. So that region, in that region no electron is present. वहाँ पे electron present ही नहीं रहता. उस region को हम क्या कहते हैं? नोडल प्लेन. See here 2s orbital one nodal plane and here 1 and 2. So these are the nodal planes where no electron is present. So it is a simple region where no electron is present. वहाँ पे इलेक्ट्रॉन absent रहता है, प्रेजेंट नहीं रहता. For example, I can say like this. So this is a p x orbital you consider and here nodal plane is present. So यहाँ पे इलेक्ट्रॉन प्रेजेंट है, यहाँ पे इलेक्ट्रॉन प्रेजेंट है, पर यहाँ पे इलेक्ट्रॉन प्रेजेंट नहीं है. So this portion or region is called as a nodal plane. Are you getting? Yes. So there are two types of nodal planes. One is a radial node and another is an angular node. So radial node is a spherical region around the nucleus having psi and psi square equal to 0. So it is a spherical region. Radial node is what? It is a spherical region like this. So radial nodes. So how many radial nodes are present in a particular orbit? We can calculate by using this formula, that is n minus L minus 1. N is a principal quantum number, this one is a L is a azimuthal quantum number that we have learned in previous classes. Okay, so we can calculate the number of radial nodes present in a particular orbital by using this formula. Next one, angular node. The plane in which probability density finding is 0 is called a nodal plane or angular plane. So it is a simple plane. So it is used in px orbital. So this is a plane. So this plane is what? Nodal plane, and that is an angular node. So it is a simple probability density function is 0. So angular node is directly is equal to L. So the value of L is nothing but the number of angular node. So total nodes, we can calculate the total nodes present in the orbital is equal to radial nodes plus angular nodes is equal to n minus L. So if you want the total nodes present in the orbital, so we have to use the formula n minus L. And if you want only radial nodes, then n minus L minus 1. And if you want only angular nodes, then the value of L is its angular nodes, where n and L are what? Principal and azimuthal quantum numbers respectively. Fine. Okay. Rules of filling of electrons in various orbitals. So to fill the electrons in various orbitals, there are some rules, and those rules are very important in order to fill the electrons in a various orbitals. So let us try to understand the 4 rules. The first one is a Fourier principle. The first one is what? A Fourier's principle. This principle says that electrons are added one by one to the various orbital in order of their increasing energy, starting with the orbitals of a lowest energy. The increasing order of energy of a various orbital is like this. So, a Fourier principle क्या कहता है? द लोवेस्ट ऑर्बिटल, जिस ऑर्बिटल की एनर्जी लोवेस्ट है, उस ऑर्बिटल में इलेक्ट्रॉन पहले जाना चाहिए, बाद में हायर एनर्जी ऑर्बिटल में इलेक्ट्रॉन फिल करना चाहिए. फॉर एग्जांपल 1s 2s and 3s, these are the 3 orbital, and out of these three orbital, 3s orbital is having high energy, then 2s and 1s. So where the first electron we have to add, the electron we have to add into first 1s orbital, then 2s orbital, then 3s orbital. Don't add electron directly into 3s orbital. No, it is wrong. According to the Upwa principle, the electron goes into that orbital which is having the lowest energy. So we have to add the electron with their increasing energy of the orbital. So 1s orbital first, then 2s, then 3s. So this is what the Afua principle. It states that add the electron in the increasing order of the various orbitals. So 1s electron get first electron, then 2s, 2p, 3s, 3p, 4s, 4d and so on. So these are the increasing order of orbitals. So this order you have to remember. Okay, which orbital come first, right? This is important. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d and 7p. So these are the increasing order of orbitals arrange. Now next one, n plus L rule. So this rule is very important, n plus L rule. In a neutral isolated atom, lower the value of n plus L for an orbital, lower is its energy. So however, if two different types of orbitals have the same value of n plus L, the orbitals with the lower value of n has a lower energy. So n plus rule gives the energy of the orbital. n plus rule क्या कहता है, हमको energy ऑर्बिटल का एनर्जी बताता है। ओके, कौन से ऑर्बिटल में हाई एनर्जी और कौन सा ऑर्बिटल हाई ऑर्बिटल एनर्जी है, दैट कैन बी गिवन बाय एन प्लस एल रूल. ओके, फॉर एग्जांपल नाउ वी आर हैविंग 3s, 3p, 4s and 3d. These are the orbitals are present. Now we can calculate the energy of the orbital by using n plus L rule. What is n plus L? N is a principal quantum number and L is a azimuthal quantum number. So I can write down here L is equal to 0, 1, 2, 3, 4. These are the value of L. If L is equal to 0, then S orbital. If L is equal to 1, P. If it is 2, D. If L is equal to 3, then it is F orbital. Okay. So now we are having the first 3D orbital. So n is, here a value of n is 3. What is the d value of L for d orbital? So it is 2. If L is equal to 2, then it is d orbital. So it is d orbital. So value is what? 2. So the energy of the orbital is how much? 5. Now consider 3s. The value of n is 3. Yes. What is the value of L for s orbital? It is 0. So 3 plus 0, it is again 3. So the energy of this orbital is 3. Now 3p. The value of n is 3. For what is the value of L for p orbital? It is 1. So 3 plus 1 is equal to 4. So energy of 3p orbital is 4. Now 4s orbital, value of n is 4 and s orbital 0. So the value of, so the energy of 4s orbital is 4. Now see, out of 3d, 3s, 3p and 4s, the highest energy orbital is what? 3d, because it is having high energy, that is 5th, and the lowest is what? 3s, which is having the lowest energy, so it is 3. So according to the n plus L rule, we can compare which orbital is having the high energy and the low energy, and according to that we have to fill the electron. So lower energy orbital has to fill first electron, then higher energy orbital. Suppose if two different types of orbital have the same value, अगर n plus L वैल्यू सेम आई जैसे कि हमने अभी देखा, so 4s orbital the value n plus L value is what? 4, and for 3p orbital it is also value is same. If we calculate n plus L for 4s, it is 4, and n plus L value for 3p, it is also 4. Now both the orbitals are having the same energy. Then in this condition, how to identify which orbital is having the high energy? So rule says that what? If two different types of orbitals have the same value of n plus L, so these are the two different types of orbital having the same n plus L value, then the orbital with the lower value of n, then the orbital with a lower value of n has a lower energy. So lower value of n, so किसका वैल्यू लोअर है, किसका प्रिंसिपल क्वांटम नंबर कम है, n इज नथिंग बट व्हाट, प्रिंसिपल क्वांटम नंबर. सो इसका प्रिंसिपल क्वांटम नंबर क्या है, कम है, दैट इज 3, एंड इसका प्रिंसिपल क्वांटम नंबर ज़्यादा है, दैट इज 4. सो द लोअर ऑर्बिटल इज अ वन हुज n इज low. So this orbital is having lower energy and this orbital is having higher energy because its principal quantum number or its n value is what, less, whereas its n value is more. So this one is a lower energy orbital and this one is a higher energy orbital. So this is n plus l rules, remember. Now next one, Pauli's exclusion principle. So according to this principle, no two electron in an atom will have the same value of all four quantum numbers. If one electron in an atom has the quantum numbers n is equal to 1, l is equal to 0, m is equal to 0 and s is equal to plus half, no other electron can have the same four quantum numbers. So it is simply, Pauli's exclusion principle क्या कहता है कि no two electrons can have all the four quantum numbers same. सेम क्वांटम नंबर नहीं रहेगा, एक तो क्वांटम नंबर डिफरेंट रहेगा. ओके, एटम शुड हैव एक, सिर्फ एक क्वांटम नंबर डिफरेंट रहेगा, सभी क्वांटम नंबर सेम नहीं रहेगा. सो अकॉर्डिंग टू दिस प्रिंसिपल, नो टू इलेक्ट्रॉन्स इन एन एटम विल हैव द सेम क्वांटम नंबर. ओके, it does not have the same quantum number. Suppose if n is equal to 1, l is equal to 0, n is equal to, so plus half. So either one quantum number will be different in two electrons. Now last one, Hund's rule. So this rule deals the filling of electron in the orbitals having equal energy. According to this rule, electron pairing in pdf orbital cannot occur until each orbital, the rule deals with the filling of electrons in the orbital having equal energy, that is degenerate orbital. Equal energy is nothing but what, degenerate orbital. According to this rule, electron pairing in p, d, f orbitals cannot occur until each orbital given subshell contains one electron in each is singly occupied. For example, if 6 electrons are there and these 6 electrons we have to fill in a p orbital, so we are having 3 suborbital, that is px, py and pz. Okay, so these are the px, py and pz, these are the 3 suborbital. So now we have to fill the 6 electron in the 3 p orbital. So Hund's rule क्या कहता है, don't fill the electrons in this fashion, pairing fashion. This is wrong, don't fill the electron in this fashion. So actual filling of electron in the suborbitals is like this. First we have to singly fill the electrons in each orbital, 1 1 1. Now then start the pairing. So first symmetrically pairing we have to do. Okay, so we can fill the electron in this px, py and pz orbital like this. So first singly electron we have to fill in all the orbital, then we have to start the pairing. Don't fill the electron in this fashion, starting को ही pairing मत करो ऐसे. So this distribution of electron is wrong and this one is what, right. So singly we have to occupy the first orbital completely, then we have to start the pairing. So this is what the Hund's rule, electron pairing in pdf orbital cannot occur until each orbital should get one electron. So each orbital should get first what, one electron, each orbital should get one electron, then we have to start what, pairing. Okay, so this is the Hund's rule. So these are the 4 rules of filling the electrons in various orbitals and these rules are very important. So filling of electrons in various orbitals. Okay, so this one is a k shell, m shell, n shell and so on. So this is a simply how many electrons are present in k shell, l, m and n. So this diagram represents how many electrons we can pair or fill in k shell. So 2 electron, m shell, next electron. So these are the k, l, m, n. So how many electrons are present we can get through this diagram. So it is simply I have put it. Next, electronic configuration of element. So electronic configuration of the elements, usually the electronic configuration Usually, the electronic configuration of the atom of any element is simply represented by the notation. Okay, we'll study this in a next class. Okay, so whatever we have discussed today, try to remember that and use the books and read the concept very well and try to understand. Fine, thank you.